Well, hi, good morning. Thanks so much for joining me in my shop here as I'm going to be replacing parts in this radio we're looking at. And in fact, I've already done a couple of them here. And so yesterday afternoon I was in here working, shot some video, made too many video mistakes in shooting the video to post it. But not much in there. Me spending a lot of time reviewing the schematic, so I'll get around to doing that again as we get down the road. So what I'm really trying to do here with the radio is replace the unreliable capacitors that are in the audio circuits, and I'm circling the area where most of them would be, but the fact is the volume control's over here, so there can be some audio circuit components up in this area. And look, there's a radio coil here, so some radio stuff can be down around here. So it's not so simple as saying, here's all the audio stuff and here's all the radio stuff. And I'll just do all the capacitors in here. Who is calling for me already? Peanut. Holy smokes, I barely got going and he's out there hollering. Yeah, come on in. Might as well say hello right off the bat. Peanut? Peanut, come on. Yeah, hello, come on right in. Come on right in here. How are you today? Yeah, I know. You're still waiting for... He's going to flop at my feet here. Let's see if he does that. He's a flopper. You going to flop? No. No flopping going on. Poor Peanut. He's just so tired of the winter. Yeah, we still have snow outside, like about a half a meter of snow on the ground. It's supposed to snow a little bit this morning. Sorry, Peanut, to say that. Peanut? Peanut! He's just preoccupied. Peanut! Hey! Yeah. So, what's the plan? That's the plan. Go out. That's the direction of out. No, not for a while yet, Peanut. Sorry, buddy. You and me, we're stuck inside. I'm stuck inside too. Okay. Now, after being totally distracted, right, so I've replaced 2 capacitors so far. I've used this kind of capacitor because it's the only 0.25 microfarad capacitor I have in my shop, and there it is. It's not quite the right kind of capacitor to put here, but it's harmless to use this here. This is really meant to go across a power line or to be involved with the power line. These are special, will not explode type capacitors. Anyway, I've got 1, 2, may as well do this one. This one's in the power supply. That's about it maybe. 1, 2. I'll have to do a little more research. Excuse me. I'll replace this. We'll take a look at the schematic, try to figure out what more are remaining that should be replaced that are in the audio circuits. Once that's done, we'll play the radio and see what it sounds like at that point. Maybe I can put some signals right into the audio amplifier itself and we can listen to what it sounds like coming out. Good, so I'm going to carry on with the replacement of those capacitors there. 0.1, 0.01. So we'll start with the 0.01. Good. Now, next to do here, audio. Well, I was going to do this guy here. He's in the power supply. Might as well get rid of him. There's a 0.1 here. We have lots of 0.1s. Okay, now another potential audio capacitor. This one. Let's take a look at this one on the schematic here. It's right off the back tab through a resistor here down to the chassis. That should be easy to spot. So we can look on here and try to spot it. So it's by the volume control. There's the volume control. There's the back tab. There's the coming off the back tab is a resistor to a terminal to another terminal. Is that how it's done? Not quite like that. Oh, how do you like that? There's two capacitors. Hey, there's two capacitors attached here. So here's a point CC16 .007. What is that? RT. What is that? Terminal. Oh, this is the actual resistor here. That's what this is. This is duh. Yeah. So through the resistor to the terminal, then through a .007 to ground. .007. Okay. That's exactly the size I don't have. Yeah, but I have everything around that. How critical can this be? What if I put a .008 or a 006 in there? It's pretty precise, .007. Now there was trouble with this volume control. When I turned the control past, what I imagined was the wiper going past this point, the tonal quality of the radio changed. I'm going to guess because this is leaky. I'm not sure though. So if I put too big of a capacitor in here, going past this will do more than it's intended to do. If I put a smaller one in here, it will do less. You know, less sounds better. Less sounds better to me. .006. We're going to put a .006 in there. No, having said that, now I got to see if I have one actually. Here's one, right here. .006. There. .006. Okay. It's this guy here. It's another capacitor here. There's a capacitor attached to this point. It's not on the schematic. Hard to see, but it comes around to this terminal here on the switch. Volume, back tab, resistor, capacitor to ground, plus another capacitor. I missed something on that schematic. Let's see. Off the tab through the resistor. And then at this terminal point, there's another capacitor connected, which runs over to here. Well, what am I supposed to do about that? You know, it's original. So that's another change. Think about this, Jim. The radio I have has a more advanced tone control to it. The schematic here shows a tone control that consists of just a switch, switching in and out a capacitor. Mine has a potentiometer. It doesn't appear in here. So on the back of the volume control, something that affects the tonal quality also has been changed. So I'm going to take a guess that those things came together. That somebody in the marketing department said to the design department, can't you guys do something more? Look at these other competitor radios. People have a potentiometer to select a tone. All we got is a stupid switch. What can you guys do about that? And so in went the potentiometer, a couple of more capacitors not on the schematic, and they did this. They hooked a capacitor from here into this. Now whereabouts did they hook it into this? And what is this? C8. What is this? Bus. So bus usually means bare wire is really what this means. A bare wire to... what is that? Okay, let's look at the radio and see if we can figure out what this is. What is this? Okay, so that thing would be down in here. Wouldn't it be down in there? Should be between the switch. Here's the switch. And the terminal should be in here. Well, I don't see anything in there except a capacitor that's not on the schematic. I don't have a lot of options here. I think I better just replicate what's in here already and replace that capacitor down here. I should finish this one. Let's finish the one I'm working on. There. Okay, next guy kind of in back there. Point oh 0.015. 0.015. Okay, so I think this is my next target for an audio capacitor, even though it's way at this end of the radio. These are the terminals you hook up your phonograph to. The signal is passing from the radio, my understanding, from the radio through this capacitor through the link out here and then back into the audio circuits or the detector or wherever it's going from there. I think this is a critical. This has got to be audio out here, so it's got to be after the detector. So this is a critical guy. Let's find him. Let's find this guy on the schematic. Take a look. Okay, so if we look for the terminals on the back panel here, here they are, right here, right here. So this is the capacitor right there. It shows it going between a terminal. Yeah, it does that. It's a terminal strip there. So this is at 0.01, and you remove the link, C17. So if we look at the schematic, and we want to find C17, that external phono attachment, where is it? Oh, it's up here. There it is right there, 0.01. So all the output from the radio, hold it, let's not get this wrong. So this is the radio output. That doesn't make sense. No, it's not the radio output. Okay, it's just a little confusing. The detector diode output picked off in this area, picked off right here. The audio is sent back. Capacitor, that's the one we're targeting, top of the volume, audio on its way. Critical capacitor, 0.01. Let's go get it. 0.01. 0.01. This would be a good one to test right away. Let's do that before I mix it up with all the others and lose track of it. Okay, 50 volts on the capacitor. What does it do? Open right up. 150. Oh, it's in very good shape. Okay, let's give it a moment to discharge, and then we'll measure its capacitance. It's supposed to be 0.01. 0.01 be on this scale. Right there. Okay, so we're on the 0.5, the 0.001, 0.05, 0.01 is right here. So it's measuring 0.01. It's not opening the eye very much though. But I'm sure if you put a proper 0.01 in here, you'll get that eye to open up all the way. Let's check it. So grab a 0.01. Yep. Let's test the tester. See it open all the way? Right on 0.01. Okay. So I think that does sort of suggest there's something up with this, and I think it's leaky, even though the leak test didn't really show it particularly leaky. Goodbye to it anyway. Okay. Now, any more audio type capacitors in here? So I've done 1, 2, 3, 4, 5, 6, 7. This one doesn't really count as an audio one. 7 capacitors. Let's take a look at the schematic one more time, and then we're going to try this radio out. In the audio area here. Don't know if I've done this one. Right across the transformer. There's a 0.05, 0.015. 0.005. I think I did this. So I've done everything coming off the pins of this tube. So I've done that, done this, done another one. What about that one? C23. Let's look at it on the diagram here. C23, that's right near the output tube. C21, C20. C23, what does it attach to? I'm totally lost here. There's 20, that's 28, I think. 22. How about 23? '21, 20, 22. Maybe that's 23. 0.005. 23. Yeah, I did it. I did it already. I think that's it. I think there's another. Well, let's look at the volume control. Where are we looking at the volume control? Coming back this way. So this is the wire I chased all the way up here. There's something going on right on the detector. There's this one too. Oscillator coil. That's a ground point. This is from the oscillator to a ground point. This is a ground point here, brought into here. This is looks like a capacitor here. What is this? So basically the output of the detector, or around the detector, are some audio, potential audio stuff. This is the cap, the grid cap, wire. Coming to this one. First detector oscillator. Doesn't quite make sense that this would be a audio circuit capacitor detector. First detector, as opposed to the second detector up here. This is the one that's generating the audio. This is the mixer. So you know, a capacitor hooked up to the mixer can't really see how that's an audio thing. So let's follow this back again. Or is this just a spare terminal? 6D6 IF. Okay, so follow this one. Shielded wire here. C55. We'll look at that on the schematic in a second. Going up here to the cap of the 75. Let's look at the schematic. Cap of the 75 is this. I don't get it. Coming off the volume pot, the wire straight to the cap. Cap wire straight to the potentiometer. No, something totally different going on here. Why does that say shield there? Oh, this is that metal plate. Capacitor just outside the... So what's it say there? Shield external. Shield, what's going on here? Let's take a look at this shield plate in the radio. Okay, I'm doing something I don't often do with my videos. I'm jumping in the middle here. I've been editing this video, just cleaning it up a little bit, and I'm jumping in here because I see now what it is I was missing first time around. So again, if we look down here at this is the wire going to the grid cap. Look what happens right here. I just missed this with my eye. So the conductor inside this shielded cable is pulled out at this point and attached to the slider. Perfect, that matches the schematic. The shield continues on up here where it finds this grounded plate, and this capacitor must just be utilizing this grounding point as a grounding point. That's what it means by shield external here. You know, just a few more synapses had come to life. I would have figured it out first time through. So I'm carrying on with the radio, not really understanding this, but not worried about it because I know from experience things I'm not quite getting, I get later, just like this. So let's carry on with the video. It's definitely the 75 right there. So somehow they got to convey the audio after being amplified here all the way over to this tube. There's some shielded wires in here. I don't see any. Yeah, there is right here. Yeah, and it's coming right from the 75. Good. Okay, so this is the 75. It has some audio effects. There's a great big fat guy here hooked up to the 75. It's hooked up to the 75 right up against the panel here. Let's take a look on the schematic. Okay, so we're looking at the 75, which is this tube right here, and we're considering, let's see, there's a pin with the jumper and a capacitor. So the jumper's here. Here's the capacitor right there, 0.25. Yeah, 0.25. Connected to a lot of other stuff. Right here, 100,000. Going into this big resistor mounted on the back wall. C15. See, there it is. Oh, that looks like 18. No, that could be 15. 0.25. Basically off the bottom of the volume control pot. Okay, this is what I've come up with to replace the 0.25 that's there, because I just don't have any anywhere of any sort. So in fact, I'll be putting in instead of a 0.25, it'll be 0.3, which I'm sure is fine. I don't know. Looks like I can see 2.5 on there. Okay, let's run through and give a test on all these capacitors that I've taken out. We'll just test them all very quickly with, well, 50 volts of leakage pressure here. We'll test them all at 150. So that's good. This one tests good. good in terms of leakage. Or maybe I should say not as bad as it could be. 150, this one's testing good too. Let's test what's left of this one. $150. Not so good. Not letting these discharge. You know, they're leaky enough they probably internally discharge pretty quick, but I don't want to be the discharger or the dischargee. Here we go, 150. So that's a bigger capacitor. See, it's not opening up all the way. I mean, these are all bound to be a little leaky, aren't they? Not as bad as I found in other radios. Let's try this guy here. Try this one here. It's a big capacitor. Not bad. Not bad at all. I should say not terrible. Bad. Due for replacement? Yeah, for sure it's worth doing these. Okay. These definitely are not. I mean, this is why this radio worked to some degree. But in terms of getting its performance way up with these old capacitors, it might be a bit of a challenge. That one's a little worse than the others, but there certainly is no terrible capacitor here. Well, that's it. So, all pretty consistent. I mean, they've all had the same life. They've been on the same life journey together. They're all very similar style of capacitor, so they've all gone the same way. So now in here, we're all set to go with turning this guy back on. So I was cleaning up the number 42 output tube, so we'll get all the dirt off of it. And I noticed something kind of interesting, as I had been reading up on tubes. I got this on a blue background so you can see something through the tube. What I want you to notice is right around here you can see a blackening. Now that's not on the outside of the tube, that's on the inside. Can you see it's like an arc here? It's actually shaped like this. It's weaker down here, and there's a fairly strong band right here. And if you look on this side, it's hard to see. I know you're looking through the tube, but it's the same thing going on here. Or another way to see this. I'm getting some shadows in behind there I don't want to get. Like that. Maybe that's a little better. So what I'm trying to show is that there's a shadow on the inside of the glass below the can, and you know what, there might be a bit of a shadow up in here too. And I think what's interesting here is that this shadow is what caught the attention of Edison when he was experimenting with light bulbs, and he discovered this shadow on the inside of the glass and became curious about it and began trying to I guess experiment around this shadow. And part of what he did was stick another electrode inside the tube to experiment with. And then he discovered if he put a negative on that electrode, nothing happened, but if he put a positive charge on it, current flowed from the heater to the plate. So he was actually discovering how tubes based on experimenting from this black material. Now that's my story. I don't know if I really have it right, but it sounds pretty good to me. So in a sense, you and I are looking at a huge discovery. when it was made at the time. This would have been in the 1885, 1880s, somewhere around there, I believe. Not so sure. And of course, what is that black stuff? You know, I'm not exactly sure, but I believe it's literally atoms coming off the various materials that are inside here, the metals and whatnot, and somehow being driven out to the edge of the glass where it's sticking. I think if you put your finger in there and wiped it, you can wipe this black stuff off. I'm not completely sure of that. And you might think, oh, it must be carbon, but I don't think there's any guarantee of that at all. There we go. Talked long about that. Now, another thing I've learned is these very early tubes, the seals on them weren't as good as they eventually were. I believe the air seal of the leads is right up inside there. That glass structure is actually what is sealing the air from leaking in past the pins and the leads. It's a really big challenge. So I'm not sure if this vintage or you have to go back even further, most of those tubes are leaking air, supposedly. And me, I've been very bad with doing gas testing, which I hope to start doing soon. And there's something else a little weird on this tube, and that's here where the getter flash is. You can see that. That's the. Can you see in there? There. You see that rectangular thing was the getter, where the getter chemicals were sitting. You know, then they flashed that, and it produced this. But this doesn't look consistent anymore. It seems to have. Let me see if I can get that on camera. Very hard to see what I can see with my eyes here. Is that this has become very thin, the getter flash, and it's full of pock marks. I've never quite seen that. They're definitely on the inside. So what that's all about, I don't know. Maybe there's something loose inside this tube and it's banging up against that. Well, I don't hear anything loose at all, and I certainly don't want to wreck this, because I think a 42 is a very, very rare tube, so I better put it back in before I mess it up. 42, 45, I can't remember which one it is now. In you go. There. Okay, so we're ready to test this guy. Let me just... We need the speaker. We need the speaker on the end of this before we test it. Okay, I gotta get things set up a little bit for that. Okay, so as you can see, I glued this edge back. There's no chance of pulling this off. Good. Get the speaker out of here. Okay, wow, I see it's noontime by the clock there, so I'm going to fire this guy up, make sure it's still working after all those capacitors I changed, and then I'm going to go eat lunch and come back and we'll do a bunch of audio checks and the audio circuit checks in here. So let's fire it up. Now of course I'm going to start it up with the dim bulbs in. I'd be crazy not to. Switches on. The switch may always be on this radio. Okay, so volume down, watching the dim bulbs now. Perfect. Okay, see this light's pretty bright. We got 100 volts on the radio. Better turn it up a bit. Don't know that which band we're on. Should know soon enough. Okay, now I did fiddle with the capacitor on the back tab of this volume control. Let's just... There's a dirty spot in it. Well, in terms of the hiss, it sounds pretty consistent. It's like right down here. Okay, let's tune around. Trouble? That's better. You get some pretty good sound out of this radio.
He's been in the top 3 voting for the Heart, but also
good bass in there.
I was just saying that in all his greatness, Bergeron's never been a top 5 guy for the Heart, which is shocking because he's a so big in that mix for the Heart, and in my opinion.
So I'm listening to the low sounds now with the tone control set low. And I'm going to turn the tone control high and see if I can still hear these low tones. I don't think so.
That's how good his overall game is. And I want to make a point based on what Doug said. And it's right off the top. Remember when they both came into the league, Malkin and Crosby?
So that's got to be 590. It looks like it's right on. Let's try 640 here. That's probably 610.
Pressing to that red button. Something's wrong with the design. But if there is such a thing
this radio's working really, really well.
Still, and I'm sure there is, then why didn't the pilot push it? Maybe he wasn't suitably trained.
Maybe. Let's not guess. Don't be guessing. This radio's working really, really well. Getting 680 without a pile of interference. It's really good.
The Chicago Blackhawks are in town tonight to face the Leafs.
Chicago Blackhawks in Toronto. Drives me nuts that this dial is backwards, but there's nothing I can do about it. There's no string involved in this. This is the way it is. Excellent. So you can also tell the AVC is working in here, automatic volume control, because as I tune between stations, you hear loud noises in that. And that's because the radio sensitivity has gone way up. If I could turn off the AVC as I tune between stations, you wouldn't hear all that much. There's still some loud interference here and there, but it would show up more like a station. It wouldn't just show up everywhere in between stations. It's not the weirdest thing there. Okay, let's try shortwave. Let's try the shortwave band. So the audio circuits in here are working good. I'm not sure there's anything that needs to be checked. This is a little quiet. Turn it full. Let's turn this up a bit too. So shortwave a little quiet. Sounds like dirt. Very tricky to tune on shortwave in this radio. And this is at around, it's like 15 megahertz. Coming down from 15 is what we're doing here. Not bad. So that sound, those are ham radio guys. I think the radio just tuned off on its own. Well, those are ham radio guys. That stuff. Oh. There's a strong station. That's almost certainly Saudi Arabia. That would be a fellow singing the Quran, my guess. He faded out. No, he didn't. Seems to be some drifting of this radio. Saudi Arabia is one of the more powerful transmitters. They're transmitting 500 kilowatts. There he is again. There they are again. It's not a he. Yeah, because Saudi Arabia, it is kind of a he, isn't it?
.com is tomorrow's news today. And now, your host, Owen Schroyer.
All right, here's what we got coming up for the remainder of the Alex Jones Show. In the next segment, Alex Jones is going to be responding and breaking down the College-Gate scandal. He is then going to stay with us and talk about the fake hate crimes, as Smollett's legal team, if you can believe this or not, says that the case against Smollett is weak. Wow.
This is a really good day for shortwave, or this radio is really good. Really good. Now let's go back and hear that again. The music didn't sound quite Cuba. So I'm listening to this. I'm trying to hear the speaker now, and if it's causing a little bit of distortion there.
Desde el lago Okeechobee hacia el sur de la Florida y la zona de los Cayos se caracteriza por ser un frente.
It's not in its cabinet, so I shouldn't. Wow, things are hopping. Lots of stuff. Wow. I better abandon radio repair and go listen to my shortwave radio this afternoon. Okay, we're done that band. Now we're heading. So that was probably 11.6. There's 10. And you know what? So pointing straight at 10 megahertz there. That's really good. Let's keep going down. So now we'll go down into the 31 meter band, I think it is. 9 megahertz. Down in here.
Men that were making money off the idol called Diana, or Artemis, depending which translation you have. Diana was the last. Here, the PIN number is US code 1843.
Okay, so listening to that, it might be a little distorted on the video itself because the level is a little high there. That sounds like a speaker distortion. Not important. So not a lot in 9 megahertz is all the action's up around 11 right now. And we shouldn't get anything down here. Maybe here. This must be a good day for shortwave. We're down around 7.3 now. Gotta be either Radio Marti out of the States or Cuba. There you go. Still running this on restricted power. Only 100 volts. Let's see what happens if we put her on full. Louder. Should not receive anything down here. Some kind of digital transmission there. Old. And it's fading out a bit now. Well, okay. Hey, I'm going to go have lunch because let's see if this turns off this time. I'm going to go have lunch. This radio is working great. Even without changing even the capacitors in the radio part. This guy's working pretty good. I mean, how much better can it work than that? Accurate dial, good tone quality, lots of volume, lots of selectivity, picking stuff up. Excellent. Now I'm worried if I get in there and mess around, I'm going to wreck it. So, but for now, it's lunchtime. Hey, thanks a lot for watching, and I'll carry on with, I'm not sure what I'm going to do next. We'll see.